Hello everyone, so now we are going to look at modifying our tic-tac-toe game so we can play with another person. So, it's an interactive game. You saw in our last tutorial that the game that we developed was really able to play by itself, but it was always going to make the same moves. Okay, so what we are going to do, we are going to use this function, which is reading from the keyboard a certain value. It can be anything. The value that we enter, it can be an integer or it can be a string. So for example, 6. So we've just said that n is 6. I mean, you can combine this one. You can read n and you can check whether n is greater than 5, let's say. Now what should happen is that I read the value n and then it should check. So let's say I read the value 4. It should give me false. Let's read the value 8. Okay, and it's going to give me true. So n will become 8. Great. Now let's have a look at the game that we wrote last time. So I'm going to open. Okay, let me edit, right? So I'm going to edit the game. Okay, and this is our game that we wrote. Now the winning configurations will remain the same. We have the same winning configuration, so we're not going to change anything. But what we are going to do is we are going to change our moves, because these moves, as we said, they are quite artificial. So we need to allow a person to specify on which position it moves. So all we have to do really is to introduce the position. So here, instead of we have to choose, who you play in the computer, right? So you have to choose, am I going to be an X or am I going to be 0? Okay, so I'm going to copy this down here, and let's assume that you are going to be the X, player with the X. So I'm going to rename this X move. So X is the one that's going to move. And instead of the player, I don't need the player because I know the player is the X one, it's me. I'm going to just say that if you move like this, i.e. replace the first element, then you are really which position on the board you are actually replacing. So this would be replacing the second position on the board. Okay, and I'm putting X. And again, this would be replacing the third position. Okay, and then here would be replacing the fourth position. Here, replacing the fifth position. And here, replacing the sixth position. And here, replacing the seventh position. The eighth and the last one, which is the ninth. And all I have to do is to replace this player here with the actual X, right? Because we are X. I'm going to do that. Okay. So I have now defined the number. So of course when you play, apologies, the last one, when you play, you will be asked on which position do you want to move. So instead of simply choosing the next available position, you will be able to introduce a variable. Okay? Fine. So what we will need is to modify the play. So now we are going to modify these ones. How? Well, this one, we still have the same stop condition. If it's a winning board for us, the X, then we can print you win, and if the 0, then the computer wins. So I'm going to copy this down, and let's call this interactive game. Yeah, so interactive game, if the player with X, which is you, then you write you win. Okay, that's all. You write you win. Okay, and we don't need this list. We just say you write you win. if the player with 0, okay, if the configuration, oops, but now you're going to see here that you don't actually need to specify the player anymore. Why? Because we already know the computer plays with 0, so there's no need to worry about that, and you play with X. Okay, so if the 0 wins, then you print I win, or the computer wins. Now how do we play? Yeah, so interactive game of the board. What do we need to say? Well, we need to read the position, because you are the one who plays. So you need to read which position are you going to play. And then we have to make a move. So we're going to make a move on the board at a position that you've just entered, and then we get a new board. Okay, and then we should be able to print board. So print board, new board. Okay, make sure that we write everything correctly. The new board. What else do we want? Well, we might want to so what have we done so far is we move and we printed the board. Okay, and then what do we have to say? Is to continue the game. You see, because it's not enough for us just to say move and print. We should be able to say continue the game with a new board. Okay, you might want to display the new board, because you need to show, we've already done that, right? So we display the new board. Okay, and we play. But one thing that we have to decide is, you see here, what's happening here is every time we enter this int game, which is recursive, who moves? Which player moves? And you can see here that the player who moves at every single step is you, the X. So when does the 0 move? Well, in our example here, we were actually alternating, right? So we were saying if the X moved before, then the 0 will move, and so on. Whereas here, we are not really alternating, but every time we enter this branch, we still move with the X. So we need to be able to respond. So we'll have to say that after we move, we display the board, and we should be able to respond. So the 0 has to respond on the new board, creating a completely new board, right? So final board, not final, but basically complete move board. Okay, and then this is the one that we are going to use to now move. So now we've actually moved both X and both 0 have moved. Okay, so did we display it? Let's display the board as well. Okay, so in here I'm going to say that we want to display this complete new board that we've just copy, yeah? Edit, copy, and then here edit, paste. Yeah, complete new board. Fine. It remains for us to implement this response. So how does 0 respond? Now, of course, you can think of doing something similar where you can ask the player to for a move, okay, just like we've done for the X player, or you can just simply move in order, just like you've done in here. You move onto the first available blank. Now, of course, that's not going to be the best strategy, would it? Because, well, you want a computer to be cleverer than that. But for this particular scenario, just to show how the interaction can work, we are going to allow the computer to simply move on the best available blank. Okay, so let's write that. So I'm going to write the or respond. So what parameters does O respond get? The board, the player is the 0, okay, or the O, whatever is the 0, and then it should create a new board. What can the positions be? Well, we simply call move board. Okay, here you don't need the 0, right? Because we know this is the 0 who moves, who responds. So move onto the board, put position 0, get new board, and possibly here you can check whether it's the winning whether it's a winning board, because if it is, you should really stop. Okay, and this is what this is done. It's returning now false, because you will have to stop the game. So if it's this is in case if it's a winning board. So let's do the case when it's not the winning board. So I'm going to copy this one down. So you've made a move, okay, and you should be able to do what? You should be able to check whether you can move in order to win. Okay, now we didn't write that predicate yet, but I should be able to write a predicate that says move on the board if you can win, if that board gives you a winning position. So let me write that predicate here, and the predicate is X. So you don't want X to win, so you write something, if X can win, right, then you should block him. That's what you have to do. So win in one position. So when can X win in 1 on the board? Well, what should you do is, if you can win, if he can make one move, any move that is on the board with X, if you can put an X on the board to get the new board that you then this has to be a winning board. So you have to check whether this is a winning board for X. Yeah, so this is how we do it. So we say X can win in one position if it can make a move onto the board, and that becomes a winning board for X. And remember, we do have the win board here. So it's a win board for a player if it's a win on a row, column, or diagonal. Okay, so now we have a predicate that tells us if X can win. Now we come back here. So we say we move onto the board if I can win. So if you can win, you should move, right? The computer should put a 0 in the winning position. If not, it should block. So X cannot win. So you should use a such position that if X can win in 1 on the board, yeah, but which board? The new board, yes? Okay, new board. Then you shouldn't allow him, so you put a not. So you say, look, you move with 0 onto the new board in such a way as to block X, so X cannot win. So if you, so you do them in order. So you move so you can win, you move so you can block him. Otherwise, you really simply just move. That's all. You know, doesn't matter. You've already made sure that you won, you block them, or you simply choose a certain movement. Okay, and the last possibility is when we have a tie, or when there's nowhere to move, really. You go to the end of the game. So how do you do that? Well, you check whether you do have a blank onto the board. Okay, so let's write the predicate here. Yes, if, and this now takes you to working with lists. If not member B of the board, so here, if there is no blanks onto the board, then you really need to stop. Okay, otherwise it's a stalemate. So you know, it's like you basically have to, you can't move, and you just stop the game basically. Okay, and you can write a message Right.